Okay, part two, the electronics. I cannot tell you how many hours I spent staring at electrical diagrams for Miatas and Ferraris, and still it was a major pain in the ass. And that's one of the main reasons I'm doing this video, is because if anybody else wants to try this, I can save them hours of head scratching, unless you're an electrical engineer, in which case this is probably easy stuff. So here's the switch from the Miata control panel, the back end of it. There's the button for the AC, and then there's a rotary knob on it. There's a bunch of wires that come off of it, and this is the blower motor part that we're going to deal with first. There's a big black wire that goes to ground, and then you have 4 wires. This is obviously mounted in the interior, and all this is going to be in the front trunk, so you're going to have to run 4 wires from the interior out to the front trunk. And this is the harness for the resistor, and it's got a 4-pin connector which I cut off, and then you just connect same colored wires. So there's a blue-yellow that goes to a blue-yellow, a blue-white that goes to a blue-white, a blue-red that goes to a blue-red, and blue with red dots that goes to blue with red dots. Also on the harness there is a single blue wire that goes to 12-volt positive. That has a little plastic connector on it. There are 2 wires with a plastic connector that would go to the Miata blower motor. So this is going to go to your blower motor. The tricky thing is hook it up to your blower motor and then see if you're getting air out of the dash. If not, you may have to reverse the wires because you may be running the motor backwards. Last but not least is the resistor. Basically, when you're running at slow speeds, the resistor is sucking up electricity to enable the motor to turn slowly, but in doing so it creates a lot of heat. So in the side of the air box is where they put resistors, because the fan actually helps cool them down. Now the original Ferrari resistor, which is this thing, is pretty massive, and you can see where it has 2 screw holes that screw it in the side of the box there. But the resistor for the Miata is smaller than that, so you have to make up a plate that covers the original resistor hole, and then cut a hole in that to put the Miata resistor into that, and that way things will keep cool and you will be a-okay. So that's for running the blower motor. Even more of a nightmare electronically was doing the AC compressor clutch signal. And here's what I eventually came up with. This is the AC thermostat. That's that thing. And obviously the probe is running out to the evaporator coil, but it's got 2 electrical connection pins on it, and you have 12-volt positive coming in here, and I'm also stealing from that and putting 12 volts into the top of this relay here. The other pin gets connected to the low voltage side of this relay, and here we are back at our Miata switch with the push button here. We already dealt with some of the wires that come off of it for the blower, but there's also a single wire with a single light bulb on it, and that's hooked to the AC switch, and that wire goes into the other side of the low voltage hookup for the relay. And then coming out the high voltage side, we got a wire that will go up to the front trunk and get split into 2. And this becomes very complicated. Up in the famous hidden fuse area, so this is the front trunk, here's the air box, and down in the hole there is the computer for the ABS, and in that valley are some relays and fuses, and there are 2 important relays that we're going to deal with. One is the relay for the AC compressor clutch, and the other is the relay for the condenser fan that sits under the front bumper. The AC compressor relay you can identify because it's got a green wire going into it, a green-white wire going into it, a red wire going into it, and a green-black wire going into it. The relay for the condenser fan has a black wire, a brown wire, a green-white wire, and a couple of red wires going into it. Now the tricky thing is our signal here to engage these is going to go in where the green-white wires were originally. So you could just plug your relay in and just cut the green-white wire, but I wasn't going to do that because I didn't want to be cutting anything that's permanently Ferrari. So what I did was I just made connector wires that had a male spade terminal on one end and a female spade terminal, whatever you would call it, on the other. So with the relay here and the relay holder here, you just connect up the green wire to the pin where it would originally have plugged into. With another little bridging wire, you just connect the red wire to the pin it would normally go to. For the green-black wire, again, you connect it up there, but you also need to run a separate wire that you piggyback onto there to ground. For the condenser fan relay, you're doing the same thing, running red wire to its original pin, brown wire to its original pin, and the black wire to its original pin. But now the wire that you've got coming from the AC button, you're going to hook to this pin, which the green-white wire originally went to. You're going to just leave that one hanging. And similarly, you're going to do it again where the green-white wire would hook into the relay. It's important to do the condenser fan relay too, because when the AC gets going, the condenser fan often comes on, so you have to have both of these hooked up. And trust me, it took me a long time to figure out how to do this and get it to work properly. And once the plate around the shifter is out of the way, you just pull this whole panel down and it'll pop out from under the lip there. And then, here you go, the whole thing comes out. Then you have to go around back and unplug the plugs to the various components back there. Okay, so here's the front air box in the front trunk, and this is the servo that operates the flap for the recirculation, which closes up in the big hole up there. This just screws on the front of the box, 2 screws, and pops out, and there's a little square shaft that actually twists the door up, closed and open. So took that off, and using the same 2 screws that it was mounted with, I made a aluminum plate here, and in the center I drilled a hole for the mechanism that hooks into the door that flips it up and down. So when I pull the lever, basically the flap closes. You can probably just see it slightly in the distance there, and when I let it go, it opens. So that's my lever attached to the shaft. And then I have a piece of cable running to or a piece of wire going in the cable housing, which is fixed here. So when I pull the end of the wire, the door closes, and when I push it back again, the door opens. So that's recirculation, that's non-recirculation. So we've gone from fancy electronic servos to primitive cable, and hey, it works.